Hello, hello, hello. Everybody codes. Apparently I'm not logged in. Can I get logged in? Awesome, I'm logged in. Quest 4. I am ready to go this time. I got everything. Just gonna keep running. That's fine, weirdo. But yeah, I got my code here. Got a little template going. Got all my functions. Got my notes ready. Here goes nothing. Quest 4. Here we go. Boom. Following notes. Okay. Really need to make these multi-line strings in the future. You need 10 strikes of the hammer. Sure, bud. Let's focus on this one. 3, 4, 7, and 8. The shortest is 3. They must be level to this height. 1 to drive 4 to 3, 4 to so they all need to go to the bottomest one, right? Okay, so const nails equals notes dot split dot map number equals math dot min nails for const n of nails const diff equals n minus smallest total equals 0 plus equal diff. I got it. I got it. Give me my input. Notes, multi-line string, trim. What do we got? 77. Hopefully that's right. Yeah, well, hold on. 1289. I got an old line in there. Good. Part 2. Rotate. Other side. Bursting forms. Nails. Just more nails. Okay, I can do more nails. Drop. This paste dot trim. Okay, I'm really scared of this complexity though, because I'm not doing anything fancy. I'm just doing bad math. Expected this number to be the hard-coded one. Ooh. There's a space! There's a space! Okay, I lost it. Ah, that sucks. Dang, that sucks. Well, I have this one. It'll probably gonna bump my part 3, which I don't know what it is. There's no part 2 example. It's just a bigger number. Let's look at this for algorithmically. There's probably some math trick here. I don't know the math trick. I got 5 minutes, right? Yeah. Let me reread it again. I don't see it. What happens if I refresh this page? Do I still get the timer? I still get the timer. Okay. Yeah, nothing for me to do here. I can fix my typo. So yeah, this is a big O event. Probably not the most efficient. I could probably put this correct number in while I'm waiting to do nothing. So I bet this is the optimization, doing it in end time. So what would be the way to calculate the smallest and then generate the diffs? So I guess it'd be like, hey, this is the smallest so far, and these are all the diffs we have, and as you go down, you add more diffs. I can see that. Well, smallest equals nails 0 Okay, pretend I do the efficient way. Diff, total diff. Yeah, I can see a way of doing this. Got 2 minutes. Okay, I might as well. Let's go through the example. 3, 4. So this 3 being first kind of ruins the vibe. Let's put the 3 here and the 4 there. I know we're breaking the example. I'll make another one. There we go. So if we do this, we're still going to expect it to be generating 10. We'll put the efficient one here. That's all broken. Smallest. The smallest. Well, if n less than smallest. Smallest equals n. S diff equals smallest minus n plus equal S diff times the number of ones I've iterated through. So let I equals 0, I less than length, I plus plus. So if we start at 1, const n equals nails I. Am I done? I got a minute and a half left. Okay. N is right there. What do you mean? No. Don't forget my braces. Times I. And then we can use this select. There we go. Okay. Let's see if this still works. It does. The efficiency. I assume this still works. It looks less efficient because the stupid thing doesn't work, but yeah, might be over-engineered, but it works. I have a minute and a half left. Those last 40 seconds. Now, if this isn't correct, oh, now I'm in real trouble. But now we wait. I wonder what part 3 is. Is it like hammering multiple nails at once? Or did they just go bigger, bigger number? I think it'll be cool to visualize though. I mean, not these numbers maybe. Watching a hammer go around and smack nails. There we go. Okay. Nails are much longer than before. To achieve this, you must determine the optimal amount force to be driven or pulled, so the total number. Not to level them all to 5 units. Who said go to 5? Minimum number of hammer strikes to level. I don't know how the heck you got that number there. But yeah, this is a new drop, trim. Supposed to be 8. 8, drop that. Solve quest 3. Let's do it. Grab my notes. Drop, kill that. Paste, trim. Okay, let's get solve quest 3 on the phone. We'll do the unofficial, because my computer can handle it. Solve quest 3. Now let me read this again. Okay. Those have additional white dots. Okay. So I have to find the height. So am I going for median? 2 nail 3 times and 4 nail once on the white dots. Okay, so am I finding the median? This has got to be the math thing, right? Median. I mean, this is just sum them all together and divide by the length. A plus B. Starting at 0, divide by No, that might not be a whole number. That's the problem. Well, that's average. It's not median. Close enough. Average would be where I would start, even if this isn't correct. Yeah. Maybe that doesn't work for all the outliers and stuff. Yeah, then for each one I would go out in each direction. 8 hammer strikes. So it's how many strikes for this. Gotcha. Let's do this. So it's basically I'm generating the smallest and then counting all the diffs to get there. Okay, so let's do this. And there's gonna be a minimal. I could just try them all. What is... come on. That's not a big number. I mean, it's not a small number. Oh wow, they actually do the thing. Okay, so yeah, this is definitely what I'm gonna do. I'm gonna go from min to max and find the best one. Less than, well, I equals alpha.min nails less than max. No, not that. I plus plus. This is gonna be very inefficient, but it'll work. Enough time. Max equals this, drop this, drop this, drop this, get rid of the average. Then we just do this. Smallest is right here. I is smallest. Let best equals number at max safe integer if total less than best. Best equals total turn best. Computationally expensive. I expected it to work. Collapse. That's right. I can't collapse those. Really gotta get input parsing happening here. Oh, geez, not at the bottom of this one. Okay, so expected 15 to be 8. 2, 4, 5. Oh, I can go back up though. I forgot. Well, shouldn't that handle though? Isn't my diff? So much scrolling. Okay, focus on this one. Get this one working. Okay, let's see what you got. Or what are we counting? Okay, I know we're doing a lot of logs here. 8 hammer strikes. So it's every time I strike. So it's all the differences. So absolute. No. Ah, jeez, it's starting to get too heavy. I mean, it's not that many. I'm only doing... okay, fine, we broke it. That's good. Sure, let's go to the equal. Why are we not running my code? Small to large. What incarnation? Min is not defined. Okay, remove from filter. Min is not defined. It's right there. Well, I mean, specifically, no, there is no min. What incarnation? Please show things. Stop running. Okay, it's just literally stuck in a loop. I don't have freaking... I love Windows. Okay, let me just head on down here. Well, let me stop. Obviously, I have an infinite loop somewhere. Yeah, so I need to debug, go into here. Let's see where my infinite loop is. Don't put the letter J. Min and max. Did you finally log it? That's not. It's 2 and 8. Not that big of a number. Yeah, you're gonna go through all the nails, generate the difference. Congratulations, you got a new one. I goes up. The difference is 1. Yeah, we're just calculating all the hits. Okay, eventually we're gonna get high numbers. Here's the last one. Okay, this is the last one because we're going less than or equal to. And we're free. We're returning best. Best was 8, I think. It worked. Why? I have a number. That's the worst that can happen. There we go. Nice. Again, that was all on me, but I made it through. A little bit on using that extension, but made it through. Now the trick I did there was brute force the entire thing. So not the most efficient of usages. I don't really see it in my head. I mean, starting from the average and moving your way out a few might be it. It could be the average, so if I assume the extensions are behaving now, I don't have that many console logs. I just have one here, one here. What's this button? Yeah, obviously it's just not liking the code I wrote. But it is working, so if I return average, it's gonna fail, but come on, stop. Start. Yes, 4 has failed. Okay, so this is the average I generated, which, well, it was the smallest that actually generated the average. That's the question. Yeah, middle nail equals 0. We'll set that here also. Middle nail equals I. Now we get to know. So yeah, we'll keep that console log, but also console log what the middle nail would have been. Drop that. See if that will run for us. That's fine if it won't. I can just run this myself and look at it. Forgot there's some logs on the old code. Okay, stop. 04 npx. There we go, and where's my logs? So, the average and the middle nail weren't that far off. What was the min and the max though? Because I saw them pretty close. min, max, the middle nail. Yeah. So I don't think it would have been the magic bullet. It just would have been where I would have started my eye. Like, hey, eye starts at the average. Then I go one less, one more, one less, one more. But yeah, I do not know the cool math trick for this. Get rid of all that stuff since that wasn't the solve. There we go. Comment that out and commit this as is. Add 04 solution. Stop that. And there we go. Yeah, to quickly break down what the actual problem was here. So what we wanted to do is get all these nails to the same height. These represent the heights of the nails. So this one's 3 units high, 4, 7, and 8. So the initial and what worked for effectively every solution I tried was finding the smallest nail and then determining how many times or the difference between any other nail and that nail. So in order to get 4 to a height of 3, you had to hit it 1 time. In order to get 7 down to a height of 3, you had to hit it 4 times. And in order to get 8 down to a height of 3, you had to hit it 5 times. So you add those up, all the strikes, and that's your answer. The efficient thing I did for this, which only lasted a little bit, was just choosing whatever one you had and being like, great, this is the smallest one I've seen so far, and doing all the same counts. But when you find a smaller one, you'd be like, you know what? I just found, let's say it's 1 smaller, so I had a 4, now it's a 3. That means you can calculate that, hey, for all of the other ones that I was like, hey, I need this many hits to get to 4, add 1 to all of their hammer strikes to get them down to 3. Where 1 is whatever the difference is. My example, it's 1. This allows you to do it in O of n time versus O of n plus O of n time, because this iterates through your entire nails array. Now the part 3 is the one I was just like, there's math somewhere around here. You are looking for an average or a median or something of that. Like 5 was the median or the average or whatever it is of like the shortest distance that they all need to move to get to a single number. We know it's not the smallest and we know it's not the largest, so it's somewhere close to the average or the median. And then you count how many hits it takes, and then there's a magic thing where you can basically pull them out by hitting it with a special head, so you can increase their height instead of just decreasing it. The way I did that, unfortunately, was very brute forcey of, let's just, where'd it go? Here it is, yeah. Let's just start at the smallest one, go to the largest one, of which we know are not the valid ones, but we're going to go through all of them, and we're going to see how many hammer hits we need to get to this height. If that is less than the least we've seen, record it, and then eventually return the least we've seen. Again, not efficient, as we saw in my little distraction there. The average is relatively close to what we're looking for. It's just not exactly. There's a math way of doing this. I don't have it memorized. Maybe I will figure it out later. But that is for another time, in which I will refactor these into cleaner versions. And if I don't figure it out on my own, I'll probably Google the math trick to finding it. First, I'll try just average, median, and all those other basics. See if I get lucky. But yeah, hopefully that has been helpful. Toodle. Hello, hello, hello. Today I am going to refactor our Everybody Codes Quest 4 solution. I finished it, just got busy, never came back to refactor it. It's a tiny reminder, it's the nail average height, or least height obtainable with, or most consistent height achievable with minimum number of interactions problem, which you have a bunch of nails here. You want to find the height that you can get all of them to with the least amount of hammer hits, which are decrements to these numbers. Part 2 does more. Part 3 allows you to increment the nails, so like to pull them out of the board to go to any unit. So we have some code here that does it somewhere. Here it is. It's unrefined. As you can see, it's still broken up into our 3 parts. So let us refactor this to the best of our abilities. So I think the main distinguisher is 1 and 2 versus 3. Because 1 and 2 are the same problem. I even wrote like an efficient version, I think, while I was on a 5-minute timeout. 1 and 2. 3, however, is basically a universe in which you can bring them up and you don't know which level they're all going to. Because for 1 and 2, they all had to go down to 3. Like if you got them all down to 4, you'd be given 3, 4, 4, 4. Like you couldn't turn the 3 back into a 4, so you always had to go to the lowest one. And then that returned how many hits it took to get there. But with part 3, you could go to any height. You could go to 2, which would be the wrong decision, because that'd be a lot of distance the others have to travel. You could go to 8, which would be the exact same wrong answer, because they'd all have to travel the same effective amount of distance to get from 2 to 8 to 8 to 2. Somewhere it's in the middle. Specifically, you want them all at 5 units, because they made this example very easy and consumable. Big fan of that. But the trick is it's not always easy and consumable. It is near the average, which we found out, but we didn't get to that level of optimization. And I don't think we will. So, the main distinguisher is whether you can go up and down, or just down. And I think this optimization, where I go through it in n time, so I don't do a generating the least of all and then going through each one, can be applied to this one. Well, actually it can't, because they're not really compatible. Okay, so assuming we're not going to be able to break into 2 functions, let's start just by getting the similars and getting the differences. So I think part 1, which is I love you, you're gone. We found an efficient version. Part 3, we don't. Well, we can use the average for an efficiency gain. It's not a lot. We're just gonna eat the bullet and just go through all of them. We'll guarantee as our answer. Right, so this bit here, this little function, these 5 lines in the loop, they are always the same. So it's basically calculate strikes to level all nails. Boom, there we go. To level all nails. And for this one, we kind of have a target, and that one can move on us. For this one, we have a target that cannot move on us. The target is I. So let's define a target number And let's determine if go lower if target found. Some degree of asked that. What the words I want to describe this, and also the words I want to describe. Decrement target if possible. Minimize target. There we go, which is basically, now we can take this and be like, da da da. I guess we need the loop too. Boop. But we needed all those things that I got rid of. And then, yeah, we have target, we have the nails. And then, yeah, congratulations, smallest, you are our target. There we go. So if you can minimize the target if possible, and the target's minimizable, then let's strikes equals 0. So we'll use that cool name, and then return strikes to get to that level. Yeah, so I think we can use this right here in place of most of our efficiency. Turns just all nails, target, the first one, nails, and true. If that's the case, then part 1 still works. I got rid of it. Whoops. Where's my part 1 notes? Oh, part 1 has 2 examples. Since when? Oh, I reversed one. Okay, cool. Love it. Yeah, part 1 still works. Part 2, which I think is just using efficiency, still works. Okay, I haven't touched part 3, so it still works. Let's maintain our paranoia, though. They all still work. Good, good. So, let's do the same thing for here. So the difference is we're all going toward the target. I don't even think this needs a directional change. It just needs the absolution. So let's see, const strikes equals, so our target is I, our nails are nails. We do not minimize if possible. And then this logic here moves up here. Instead of total, it is strikes. Now, all I need to do is bring in the absolution of the difference. That will allow it to be increments, not only decrements. And yes, I'm doing a function call here. Might be easier just conditional, putting them on the right side. But this works. Well, I think this works. This does in fact not work. Oh no. Okay. So we get a nail, we get a difference, we add to the strikes. So for every nail, we get the difference, which is absolute, we add it to the thing. If strikes less than best, best equals strikes. Okay, hey, I did it wrong. Let's compare and contrast. So I'll have strikes and I'll have total at this debug point. Let's get to part 3 and debug it. Not all of part 3. Whoops. Well, I'm in here now. Let's go. Okay, 15, 15. We did it. 11 and 12. We didn't do it. We did not do it. So I is the target. N is the nail. Okay. So I'll probably need to put a breakpoint here now that I know where I went wrong. The nails. So 2, 4, 5, 6, 8. And I need to get to... what's I? 3. Okay, let's stop that. Go back in my test to redebug. And let's get to our second call where we difference. Okay. So let's get in here. Our target is still 3. Our nails are 2, 4, 5, 6, 8. Let's step through it. Okay. We should never go into here, but let's just go through them all. Oh, did I just skip the first one? Is that illegal? I don't think that's allowed. I don't think I can do that. But I needed to do that for part 1 for some reason. Oh no. No, I didn't. Maybe that was just an optimization. Easy. I think there was just some kind of optimization that I did not turn out to need. Okay, we actually can't tell if it's working because we solved the old code here. Do not celebrate too early. It works! Okay, now our celebration is warranted. Okay, so we've done that. We have some things here. Let's do a little bit more. So we still have 2 and 3. So like this function here, I think is good. We like this function. Big fan of this function. Yeah, we allow it to go down. It's a weird edge case. It's not the end of the world. So our nail parsing can be thrown to a little function if we want. That's great. Let's rename this least strikes. And you know, we can do the fancy least strikes equals math.min least strikes, and then calculate strikes to level all nails. And I'm not a fan of this function name anymore. Calculate strikes to... Okay, my mind was thinking calculate strikes to get all nails to level. So then it would kind of read grammatically like, oh, calculate strikes to get all nails to level I. But I'm not really up for that now. Now the optimization here is when we hit strikes above, we stop looking, which would combine our functions. But let's start breaking these down. So cost parse nails equals notes string. Boop. Boop. Const nails equals. Very efficient code. It's never been seen before. Now, the trick here is I think we should start from the average and move our way out until what we've moved out to is less than I or greater than max. But what I mean is, let me open a TLDraw and clear out this old stuff. So let's say, let's actually use the example. Let me find the example. Where'd it go? Oh, it's part 3. And we scroll. I really gotta get these inputs out of here. Okay, and we're here. Okay, let's throw it on the... No, not dots. Let's throw it on here. So basically, like, we have this, and the range of possible values, despite whatever it is technically... can theoretically be 2, 3, 4, 5, 6, 7, 8. Alright, so let me add spaces for that. Let's just mono both of these and put them in the same block to make my life a little easier. 4, 5, 6, 8. There you go. So right now what we're doing is we're starting right here. And we're being like, y'all go to 2, y'all go to 3, y'all go to 4, y'all go to 5, 6, 7, 8. My idea is start at the average and then literally go, no, don't go that. Go -1, +1. -2, +2. -3, +3. -4, +4. As soon as both are outside of the ranges, boom, we're done. We've looked at them all. And part of this will be, you'll find the best one. Great. If you're calculating the strikes to get to 2 and you go above whatever the least already was, stop looking. You striking the hammer more will will not make the number go down more. So that is my optimization route I'm going to apply here, which will mean we take this function back out of here, but will make part 3 a lot cooler. And we could probably do the same thing for these. Yeah, so that optimization can live in both. And I will do that after the break. That was the shortest break in existence. So I am back, and I'm gonna do what I said I would do, which is what I generally do, by optimizing this away, starting at the average, and then moving around. So that will mean we technically look at all the numbers, so like our time complexity is out the trash, but I believe amortized, since we're optimizing the nested basically, which is what this is, it's going to amortize out to good numbers. So cost average equals I think it's, what do we want to do, nails dot reduce a plus b. Jeez, what in my mind? Length, well, it's total divide length, divide nails dot length, and we want to make this a real number, so we'll floor it, and then we will do that. So now the fun trick is throwing a new while loop on this. So while true, we want left equals, well, this is a for loop, so for let o equals 0, true o plus plus, and o is for offset in this equation. So left equals average plus, well, average minus o, const right equals average plus o. There we go, I'm liking that. So now we have them, they should both be const. Now we need to do the check. If left less than smallest nail. So technically we want the other one, we want these to be truthy. So if right less smaller, greater than, no, smaller than or equal to nail, and it's not smallest and largest, it is shortest and tallest nail, which we're going to do with the cost least efficient way, because no one's gonna stop me. There we go. I'm sure we'll put tallest nail back in here, just so I can not destroy that yet. Okay, and for this, basically, once we got it, we're going to call our cool function that does the cool stuff. The cool function with the coolest stuff. Yes, that is the function that I have not yet written, which I will need to be writing. I know I need to write this, and it needs to be a function that takes in a target and does some stuff. As you can tell, I'm very much knowing what I'm doing. It's part of my fault because I'm context switching to another thing I'm keeping my eye on, which I should not be doing, but I am doing it. Do the thing left, do the thing right, and then else let equals 0, and then this is the weirdest way I've done this. If outside equals 2, if they're both outside, then get out of here. I love it. And then we return the least strikes. Okay, so we're going to do the bits up here. We're going to steal all this code. We're not using the function because we ain't there yet. We ain't making it pretty till we make it work. So we have our nail, we have our difference, we have our strikes, and then we return strikes. We don't just return strikes, because that'd be boring. If at any point, if strikes is above least strikes, give up. You have failed the city. You cannot do any more. At this point, if strikes less than least strikes, which by the logic of that conditional, oh, it's a break. So you could break into here and then be like, why are we doing this? Ah, here we go. Boom. We return. Which means you only get to this line if that statement is false, which means it's less than or equal to. Which means I don't need to write this statement, which means I can say least strikes equals strikes. 11 it. So yeah, this is the Quest 3 code I've technically changed. Hey, it's alive. Love it. And yeah, I'll do actual benchmarking when I have time / care. I'm not doing that now. So yeah, we have that. We have these 3 things we need to generate. We have the least strikes. This is some repetitive code. I don't like it. So I'm gonna make it more complicated to read. Yeah, that's the right option. It's real complicated. Because I can is the reason. Because I can. Let's do it. For cost attempt of whoa. Where's my thing? There we go. Average O plus O. And then we're just gonna be like, hey, if you are within the range. So it's gonna be this and attempt less than or equal to tallest nail. I hate when these get written like this because my eyes don't like them. So we're gonna invert it. So that way the inside value is on the inside of the expression. So it's just a visual thing. It computes to the same thing, but it basically says like, hey, the shortest nail is less than or equal to attempt, and attempt is less than or equal to shortest nail. So like, it visually goes together as smallest thing. Thing you're checking is in the middle of the smallest thing, largest thing. If you look at it that way, it's easy. So basically, if you're me. And then here's where we increment our little outside counter. We outside. And yeah, that still works. As expected. Let's rename it to target height. That's right. Okay, now we could do some math probably to calculate this offset conditional and not have to do this. I'm gonna make that attempt. So it's basically the distance between the average and the min and the max. So let's, this would be great for Wally actually. If I go to it and I focus, no, go. Ooh, Wallaby's not having the moment. Okay, that's okay. Stop. I can do it with my eyeballs. Yes, basically I just want to get in here and start doing some math. So let me in. Okay, so we have smallest, tallest, and average. I need to basically calculate the largest of the two, like the difference, the largest difference to get there. So smallest. Hey, where's all my symbols? Fine, I'll use my eyes. Shortest. Oh, okay. That's on me. Shortest nail, average. So average minus shortest will get me 3. Gotta watch out for the thing. So it's 5 minus 3. So 2, which means my offset is 3. Okay, what about tallest minus average is 3. Okay, so the last of my offsets should be 3. We're kind of 1 because we're not dealing with weird things. I need to max 1, or I need to seal 1 and floor the other. So const max offset equals dot max. So y'all, whichever one of you gets bigger. So that is average minus shortest nail, and these are numbers, and they're all numbers. These are integers and no longer floats. So it could be off by 1, at which point I will plus 1, which I don't need to do on the individuals. I can just do it at the end because it's offset. It's in both directions. I like it. I like it. And let's do the other one, which is tallest nail minus average, not the AV, plus 1. There you go. O less than or equal to offset. So we do want to go to the offset, not up until the offset. We're being inclusive here. Max offset. Yeah, that's what we want to call this, which means we don't need to do this. We just need to keep that condition. And technically we don't even need to do this, but we are saving for some of the edge cases here. So it's useful. It's adding complexity. It's not use. Is the complexity add from this line worth it? I'm just going to keep hit running a bunch of times. So the one I'm really looking at is part 3, because they're the 520 I've seen. Yeah, what's the worst that could happen? We just run some pointless calculations and we fail really quickly. Oh no, we've gone up like up to 10 milliseconds. Oh no. I don't care. It looks so much cleaner like this. Yeah, I like this. I like it a lot. Let's talk about doing the thing. This should just be a simple. I think I can implement this into this one. Nails minimized. Least. So far. Number. There we go. And hey, if you've made more, hold on, when this minimum changes, I think that can mess some things up. So this might not be the best for part 1 and stuff. This is why we got test written. And if strikes greater than or equal to least strike so far, return. Yeah, just return it. You're not gonna. Ooh, don't return it. Just return least strike so far, right? Just no op effectively. It's not effectively, but it's equivalently. Yeah. Number max safe integer. This is all you've seen, buddy. Since it's one call, we don't get to see much usage out of it. But if we go down here and we start using this function, which I can just call least strikes equal calculate all target nails least strikes. Do not do the minimization magic. Let's see if that works. It's the worst that could happen. Less. Okay, this is what I why is part 5 going? This is why you don't always trust these little numbers. They're informative, but you can't go straight with them. Because I already had the optimization here. I didn't have less greater than or equal to, right? So remember there was a 1 there, but that's why you use real benchmarking, not cowboy benchmarking. which means you don't need to do the minning anymore, because this effectively prevents you from going less than the least strikes anyway. A weird side effect, especially given the name. Calculate least. Yeah, let's rename it. That's technically what it's doing now, because it never doesn't just give you the count, it calculates the least of the two incrementally. I don't like it, because it has two responsibilities now, but it's fine. It's fine. Okay, I'm liking this. It's doing all the things. We are near end of this refactoring, honestly. Solve quest 2. Now it's basically deterministic of can nails go up. So let's break that function. And this is basically the final entry function. Minimum number of strikes. Oh my gosh, it's the name of this function is what I want to name this function now. I'm just gonna name it solve quest. What do we call this conditional of? You can make them go up. Can pull up nails. Sure, that's my boolean. And then yeah, so we kind of do the same thing, but we do deviate a bit here. I don't even know if we want a single entry function, honestly. Oh no, do I try, but I'm pretty confident I don't. Because this is what it's going to look like. I'm gonna put it in and it's going to look boring. Here we go. If you can't pull up the nails, then you're just doing this. This is what a single entry function looks like. We're not really getting a lot here. We get to reuse our parse nails call. That's it. I don't like this. So one is basically downward. One is, yeah. Let's do no. Can you put an ampersand in here? Oh, I was about to be like. Sure, I don't like it, but it's not lying and we're not doing a bunch of weird stuff. So this is functional. We can go one more step further, which would be the last one I'm willing to really go, because we're getting into micro-optimization territories. We're doing these three things. We can do all of them in one, basically. So function calculate number average min. I put string, just like there's one thing that need to be true of this. You're going for minimums, for numbers here, buddy. I'll let average equals 0, let min equals number, no, not manual, whatever the heck that is. Max, let max equals number dot min. And let's do this. So the trick is that before we were basically saying, okay, you want to find this information about the array, iterate through the entire array once, iterate through the entire array again, iterate through the entire array one last time. That's 3 iterations for something that can be collected as a single iteration, which is what this is doing right now. And yes, there are even further, like I said, micro-optimizations. I'm not going to go for them. Average plus equal number if number less than min. min equals number. If number greater than max, max equals number, return average divided by numbers dot length. Okay, I'm trying to think of what's the... dang it. It always loves falling off. What's the one that doesn't prefer node? Is that round? Yeah, round. So if I give it 0.1, we go to 1, right? 1.6 or 1.7, we go to 7. Okay, that's the one I want. Just go to whichever one is the closest. I don't care which. There we go. So we'll go ahead and do this now. Yes, very advanced function. No one's ever seen such great and complex code. It goes a little faster. But yeah, that, I believe, is the last refactor I plan on applying. Yeah, big fan of it. Oh, this one technically redoes that center one twice. It just said that was the last refactor I was going to do, and that's the last refactor I'm going to do. We're good. Let's call it good. There we go. And that is it. Always a pleasure. See you next time.